Tonight, you and I are tracking a lone traveler on the longest journey ever attempted. A craft the size of a small car, launched back in 1977, now drifting through the cold void. Voyager 1 is the furthest thing we have ever built, a piece of us that is never coming home. It gets weirder. After nearly 50 years of flight, and finally crossing the boundary of our solar system, after entering the true interstellar abyss, Voyager has only just begun. In 1 million years, this lonely machine will have covered ground that makes our whole sun's domain look like a grain of sand. By the end of this watch, we will understand its path, its future, and why this mission matters so much. If you feel the pull of the deep black like I do, take a second to like or subscribe. It helps us reach more curious minds like yours. Now, look back. September 5th, 1977, Cape Canaveral, Florida. A massive Titan 3E rocket sits on the pad, carrying a payload of 825 kilograms. That is Voyager 1. Right now, it is just a cluster of cameras, sensors, and one very big antenna. Framed in aluminum and titanium, it was built to survive the harshest environment we know for many decades. That 12-foot antenna is its lifeline, pointing home to keep us talking across billions of miles. Stretching out on long booms are its scientific sensors and its nuclear heart, the radioisotope generator. Fueling it is plutonium-238, converting heat into roughly 470 watts of vital electricity. That is just enough for 5 light bulbs, yet it runs everything. The fuel decays slowly over 87 years. Our power is fading. By the late 2030s, there won't be enough energy left to keep the transmitter talking. Then, total silence. It carries the eyes and ears needed to map rays, plasma, and hidden magnetic fields. Its brain has only 69 kilobytes of memory. Less than a phone, yet it hasn't missed a beat. NASA gave it 5 years. Nobody expected this machine to still be alive nearly half a century later, still calling out from the edge. Then, ignition. Fire erupts, and I can feel the ground shudder. It climbs, gaining speed and punching through the blue until the stages fall away, and it is finally free. It is aimed at Jupiter now, screaming away from our world at 25,000 miles per hour. That is fast, but space is too big. At this pace, reaching another star would take eons. But we gave it a secret weapon, a gravity assist, what we call a gravitational slingshot. The physics are beautiful. You skim a planet, let its gravity pull you, and it whips you forward. If you sneak up behind a world in its orbit, you can actually steal some of its momentum. The planet barely notices, but the craft takes off like it just grabbed onto a speeding train. Jupiter flies at 8 miles per second. Our traveler dives in, curving around that massive, swirling giant. That flyby added 9 miles per second to its speed. That is the boost that changed everything. It makes all the difference. We first tried this technique with Mariner 10 back in the mid-70s, but the Grand Tour was different. We planned to chain these slingshots to hit world after world. The planets only align like this every 176 years. We could not let that window close. March 5th, 1979. After 400 million miles and 18 months, it finally reaches Jupiter. Jupiter is a monster, 300 times heavier than Earth, ruling over a kingdom of dozens of moons. As it gets closer, the photos are stunning. That great red spot is a storm bigger than our world. It has been raging for 3 centuries, spinning with winds that would shred anything in their path. The clouds are mesmerizing, light zones where gas rises, and dark belts where it sinks back down. Jet streams drive the chaos. Lightning there is millions of times more powerful than anything on Earth. The magnetic field is terrifying, 20,000 times stronger than home, nearly frying the ship's brain. Then we saw the moons. Io, the inner one, is a hellscape covered in active, erupting volcanoes. It was the first time we had ever seen a volcano outside of Earth. An engineer named Linda spotted it. She saw a plume shooting nearly 200 miles high. The planet's gravity is literally stretching Io apart. Europa is a smooth, cracked ice ball. We think there is a hidden ocean down there where life hides. Then there is Ganymede and Callisto, ancient, scarred worlds that show the history of every hit they have taken. As I pull away from Jupiter, everything we knew about this massive system has changed. But I am not just a sightseer out here. I am using Jupiter's massive gravity as a slingshot to hurl my ship towards Saturn. I am swinging past those swirling clouds on a razor-thin path, missing the planet's edge by just 173,000 miles. That is 278,000 kilometers. I can feel the planet's gravity bending my course, flinging me into deep space at incredible speeds. As I break free from Jupiter's influence, I am screaming through the void at 34,000 miles per hour relative to the Sun, 55,000 kilometers per hour. This gravity assist just added 9,000 miles per hour to my long journey into the dark. That extra kick is my ticket to Saturn and the stars beyond. It is November 12th, 1980, and we are moving. Finally, I have reached the ringed giant. It has been a long, lonely trek from Jupiter, 20 months of silence in the void. I have crossed 930 million miles to find this massive world. Saturn is the second largest planet I have ever seen. It weighs 95 times more than Earth, yet it is so light it would float in a massive ocean. It is truly strange, isn't it? The view from my cockpit is breathtaking. I can see thousands of delicate ringlets and mysterious gaps carved into the rings of Saturn. Hidden moons are dancing with the rings, sculpting them. From Earth, they look smooth, but out here, the complexity is truly terrifying. We have known about the Cassini division since 1675, but what I am seeing now is far more chaotic and beautiful. I am surrounded by billions of ice shards, from dust to house-sized boulders, each one a tiny moon trapped in Saturn's orbit. It is mostly frozen water and rock. These rings span 41,000 miles across, yet they are only about 33 feet thick. Imagine a football field made of paper. That is how thin this is. I am seeing structures here that only gravity could explain. Shepherd moons are prowling the edges, keeping the rings in line. I see waves rippling through the ice, pulled by distant moons. These patterns are haunting. I am diving within 77,000 miles of the clouds, that is 124,000 kilometers from certain death. I am close enough to see everything, but safe from the worst radiation. Saturn's magnetic field is strong, vibrating through my ship. It is 578 times stronger than Earth's field. I can feel the radiation belts humming, though they are not as intense. The rings act like a shield, soaking up the radiation. But my real mission is just ahead. I am coming for you, Titan. Titan is a behemoth, larger than Mercury and wrapped in a thick, suffocating atmosphere. It is unlike any moon I have ever seen, over 5,150 kilometers wide, but I cannot see the ground. It is buried under a heavy haze of nitrogen. I am skimming the top of Titan's world, just 4,000 miles or 6,500 kilometers above its hidden surface. My sensors show 98% nitrogen. There is methane down there, and organic secrets we are only just beginning to uncover. It is freezing down there, minus 290 degrees Fahrenheit. That is cold enough to turn the very air into liquid. At this temperature, I see a world where methane might rain from the sky and fill alien seas just like water does. It is like looking back in time to an early Earth. Titan is a frozen laboratory, waiting for life that has not happened yet. As I leave Titan behind, Saturn gives me one final shove. But this time, my trajectory into the void is very different. I am being flung upward, leaving the flat plane of our solar system forever. My journey through the world of the planets is finally ending. To see Titan, I had to take this path. It was a trade-off, a one-way ticket for me, out into the great, dark, unknown. Because of that angle, I am now heading north, climbing high above the path where all the other planets in our system live. I will not see Uranus or Neptune. They are far below me now, and there is no turning back from this upward climb. My twin, Voyager 2, took the lower road to find those distant worlds. I am on a much lonelier path through space now. I am flying at 10.5 miles per second. That is 17 kilometers every single tick of the clock relative to the Sun. I am the fastest thing we have ever built. In 30 years, I will cross the final boundary and leave the Sun's protection. I am reaching the edge of the Sun's magnetic reach. My main mission is over, but the real mystery is just beginning. I have seen the giants, mapped their moons, and sent back thousands of photos. I have changed everything you thought you knew. But my ship is still functioning perfectly out here. My nuclear power source still has decades of life, and I am heading somewhere no human has ever gone, beyond the planets, into the vast void between the stars. My interstellar journey is finally, truly beginning as I leave home behind. You and I need to talk about what is out there. Interstellar space is not just empty, it is the great unknown frontier. People think Neptune is the end, but I know better. The sun is still reaching for me, breathing out a stream of particles. The solar wind is pushing me, a storm of protons and electrons creating a massive bubble we call the heliosphere around our star. This wind started in the sun's corona, where the heat reaches millions of degrees. It is the very breath of a star. Atoms are being ripped apart back there, creating a plasma stream that carries the sun's magnetic field right past my metal hull. Out here near Earth, I see the solar wind screaming past at 250 miles every single second. As it thins out into the deep, it still rules everything across the inner solar system. Within this heliosphere, we are caught in the sun's magnetic grip, twisted by that constant solar flow. Beyond that, the wind dies, replaced by the interstellar medium thin gas and dust haunting the void between stars. It is nearly empty, 1 atom per cubic centimeter, filled with hydrogen and cosmic rays born from dying stars. These rays scream by at near light speed. Ahead lies the heliopause, where our sun's pressure finally meets its match. It is no solid wall, but a murky zone thousands of miles thick. For decades, we were flying blind out here. We guessed it was 80 to 100 units out. Remember, 1 unit is the distance from Earth to our sun. That is 93 million miles. We expected the edge to be 3 times farther out than Neptune's lonely orbit. Voyager 1 went to find it. August 25th, 2012, 11 billion miles from home and still pushing deeper. 18 billion kilometers away, after 35 years of silence, the ship's sensors finally pick up something strange. Cosmic ray levels spike 5%, then another 5%. Usually, our solar wind shields my instruments from this radiation. This spike means Voyager is crossing over. Suddenly, the sun's familiar particles just vanish into the dark. The plasma detector confirms it. The solar wind is gone. This is the moment we have been waiting for. But something is wrong. The magnetic field should have flipped, but it is still pointing the same way. In here, the field is a solar spiral. Out there, it should be the deep magnetic pulse of the galaxy. It should have changed instantly, but it did not. Back on Earth, they are baffled. Is Voyager truly out there? Months of arguing over data followed. Maybe the craft is just stuck in a weird transition layer between worlds. Others think it is just approaching the edge, but has not crossed yet. The debate drags on into 2013. Radio signals now take 17 hours to reach Earth. Out here, the silence between every single word is agonizing. September 12th, 2013. The word comes down. Voyager 1 officially left us behind, back in 2012. The data is clear. Voyager is in interstellar space, finally free from the sun's protective bubble. It is the first human-made object to reach the stars. But here is the terrifying truth most people miss. Interstellar space is not the exit, not even close. The sun's gravity still has a death grip on this craft. Past the planets, past Pluto's frozen belt and the heliopause, lies a massive graveyard of icy shadows. They drift in a giant sphere called the Oort cloud, named for the astronomer who first saw it in his mind. In 1950, Jan Oort predicted this shell. It is filled with billions of icy remnants from the dawn of our solar system. These objects haunt the dark, 2 light-years away. We are talking up to 100,000 astronomical units. 1 light-year is 6 trillion miles. A distance so vast, it is hard to even wrap your head around. Voyager 1 is only 160 units out. In the grand scheme, it has barely left the driveway. It will take 300 years just to reach the inner edge, and 30,000 more to finally crawl through. Our entire civilization might be dust while Voyager is still out there, drifting silently through the eternal dark. Now, let us jump forward 1,000,000 years. What is left of the universe, and where is our lonely traveler? First, let us look at the scale. Voyager is screaming through the void at over 10.5 miles every second. In 1,000,000 years, it will have covered 333 trillion miles. We cannot even imagine that kind of distance. That is 56,000 light-years. Compare that to our solar system, which ends at just 2 light-years. By then, Voyager will be 28,000 times farther out than the very edge of our home system. The Milky Way is 100,000 light-years wide. Voyager will have crossed more than half of it. But here is the catch: it will not actually make it halfway. Space does not work quite like that out here. It is drifting through the local interstellar medium, that ghostly gas between stars, moving at what we consider a modest speed. Most stars near me are hauling at hundreds of miles per second. Space is a very busy place. At 10.5 miles per second, Voyager is actually a slow-moving target compared to the stars. In a million years, it will not just be getting farther from our sun, it is going to be overtaken. Countless stars will race past it. Some might get dangerously close. You and I should look at the numbers. Every star in this neighborhood is orbiting the galactic center, a journey taking 225 million years, but we are not all moving together. Looking out my viewport, I see stars drifting like cars on a dark highway. They head roughly the same way at different speeds. This means, over eons, these massive stars eventually drift dangerously close to one another in the deep dark. Every few million years, a neighboring star brushes within 1 light year of us. Every few tens of million years, that gap shrinks to half. It is close enough to shake the Oort cloud, raining deadly comets down into our inner solar system. Out here in the black, Voyager 1 will occasionally drift past other stars just like I do. We have tracked their paths and Voyager's trajectory to see what lies ahead. You and I can see the results are haunting. The closest approach Voyager 1 makes to a stranger will happen in about 40,000 years. That target is Gliese 445, a dim red dwarf currently 17.5 light-years from my position, much smaller than our sun, but that little star is charging straight toward us. In 40,000 years, it will scream past within 3.5 light-years of our home sun. Voyager 1 will be right there in the neighborhood, passing within 1.5 light-years of that small dwarf star. 1.5 light-years is a staggering 9 trillion miles. From my position, the star would be nothing more than a faint spark in the black. If Voyager's eyes weren't dead by then, that is all it would see. It is the closest encounter it gets for a very long time. After that, the probe continues its lonely trek into the terrifying emptiness between the stars. For the next few 100,000 years, it won't find a single neighbor in the dark. It just keeps drifting at a constant speed. Let's look ahead together to 100,000 years from now. Voyager 1 has traveled 5.5 light-years now, farther than even Alpha Centauri is from home. From this vantage point, our sun is just another flickering light in the black if anyone were looking. It is not special or bright. Earth? Long gone, swallowed by the sun's glare from this incredible distance. The spacecraft, assuming it hasn't been shredded by space dust, will be nothing but a frozen, silent tomb. Its nuclear heart will stop beating just a few decades after the year 2026. Even now, we are watching NASA kill its systems one by one to save what little life is left. By the 2040s, Voyager will go silent forever. It becomes a derelict, a piece of circuitry drifting through the void, but it doesn't just vanish. It doesn't rot out here, not in any real way. In this vacuum there is no air to rust it, no water to corrode it, and no bacteria to break it down. Voyager will stay exactly as it is for millions, maybe even billions, of years. Those gold-plated records we sent will remain perfect. Our voices trapped forever in those silent, preserved grooves. If something out there finds it eons from now, they might still hear the story of humanity. Of course, the odds of that happening are zero. Space is so impossibly big that the odds of Voyager ever seeing another civilization are effectively zero, but the possibility remains, and that's hauntingly poignant. It is our message in a bottle, tossed into a cosmic ocean. It will almost certainly stay lost forever. 200,000 years from now, Voyager 1 has traveled 11 light-years. It has drifted into a part of the galaxy where the stars are completely foreign to us. The constellations, those familiar maps that guided us for thousands of years, would be totally unrecognizable to anyone looking out from Voyager's position. Orion and the Big Dipper have vanished, replaced by strange patterns that would mean absolutely nothing to humanity. Every star is moving. Over tens of thousands of years, the entire map of heaven shifts and changes. After hundreds of thousands of years, that transformation becomes absolute. Even the sky on Earth, if we are still there to see it, will look alien 200,000 years from now. Familiar stars will have moved, dimmed, or even exploded into dust by then. New stars will blink into existence where there was only black. The fabric of the night will be rewoven. Voyager doesn't care. It just keeps pushing forward in a straight line through the shifting, silent dark. Despite the tiny tugs of distant stars, its path remains remarkably true. Nothing out here can slow it down. No air, no friction, just the endless silent glide. It is a prisoner of Newton's first law. An object in motion stays in motion out here. In this near-perfect vacuum, there is absolutely nothing left to stop our lonely traveler. So, it keeps drifting at 10.5 miles per second, 17 kilometers every heartbeat, just like when it left our sun. It loses almost nothing to the thin dust out here. In 500,000 years, Voyager will have covered 28 light-years. By then, it has officially left our neighborhood. Giants like Alpha Centauri and Sirius are now far behind my own position. I see it entering a foreign corner of space, surrounded by stars that looked like tiny dots from Earth back then. If someone is out here with the tech to spot cold metal in the dark, they might just find my old friend. To them, it would be a ghost, a strange hunk of metal and plastic, clearly built by hand, definitely not a rock. They might dig deeper and find our golden record. They could learn about us, the species, from that pale blue dot. We sent it as our final messenger, a cold ambassador to the stars. Or maybe they never see it at all. They could drift right past it or dismiss it as space junk. They might study it and never grasp our significance. Or the most chilling thought, there is nobody out here to notice. The silence in this part of the galaxy is vast. Tech builders like us might be a cosmic fluke. Out here in the dark, we simply do not know. We have spent decades straining to hear anything, pointing our radio telescopes at the void, praying for a single signal. All we have ever heard is silence. Maybe we are truly alone, or maybe the distances are just too great for us. Maybe they are out there, just not broadcasting. We lack the data. Jump ahead 750,000 years now. Voyager is now 42 light-years away, drifting deep into the Orion Arm, the same spiral arm where I am now. From my view, the galaxy is a massive spiral, with thick ribbons of stars spinning out from a glowing heart. Our sun sits in a small spur called the Orion Arm, sandwiched between the massive Perseus and Sagittarius branches. Even after all that time, Voyager is still in this same local region. It has not even reached the next arm. That would require traveling thousands of light-years, far beyond anything Voyager can achieve in 1 million years. But even here, the star density varies. Some areas are packed with bright clusters, while others are empty voids. Voyager has to navigate through all of it. One moment it is surrounded by suns, the next it is floating through a dark desert where nothing is close. In the thick of it, there is a tiny chance of a close encounter, but the odds are still almost zero. In the empty zones, it could spend eons without seeing a single star nearby. 1 million years into the mission, Voyager 1 has covered 56,000 light-years. But wait, I need to stop and explain the catch here. That 56,000 figure is just a straight-line guess based on its current speed relative to our sun. It assumes a perfect, unbending path for 1 million years. Out here, I know things are much more chaotic. The galaxy is a massive, moving machine. Everything the sun, Voyager, every star, is in a slow dance around the galactic core. It takes the sun 225 million years to orbit once. Voyager is now on its own lonely track. After 1 million years, not even 1% of an orbit, their paths start to split in a major way. To find Voyager now, you and I would need a supercomputer to run a complex, deep space simulation together. We have to factor in the galaxy's hidden mass and the constant spin of the entire galactic disk. Astronomers have run the numbers, and they show Voyager's path bending under the weight of the galaxy itself. It is not a straight shot. Galactic gravity is constantly tugging at it, slowly curving its trajectory through the void. A dark matter halo is doing the pulling. In 1 million years, Voyager will be dragged toward the galactic plane. The craft will also drift along with the galaxy's rotation. Pinpointing its exact location is nearly impossible without running a full simulation. Our best estimate? It will be roughly 50 to 60 light-years away from where the sun is then. Remember, I am talking about where the sun will be in the future, not where it is today. In 1 million years, our sun will have bolted 1,000 light-years along its own cosmic orbit. To see where Voyager is, you have to track 2 moving targets drifting through the darkness together. The gap between them will grow to 60 light-years, plus whatever distance the sun's orbital dance has added. What does the universe look like then? From Voyager's view, the big picture has not really changed. The galaxy remains a giant, barred spiral, with those familiar arms wrapped tight around a glowing heart. The monster at the center, Sagittarius A, is still there, 4 million times heavier than our sun. It is still hungry, swallowing gas and stray stars. Meanwhile, the Andromeda galaxy is creeping ever closer to us. Right now, Andromeda is 2.5 million light-years away, charging toward us at 68 miles every single second. In 1 million years, it will have closed the distance by about 110,000 light-years. That is still far enough away that the two galaxies haven't tangled yet, but that slow approach never stops. In 4 billion years or so, Andromeda and our home will collide and merge into one massive galaxy. But that is a distant future, long after Voyager becomes just a tiny footnote in the history of the stars. The neighborhood out here will look different. Some stars I see today will have vanished in massive supernova blasts. Those giant, massive stars only live for a few million or a few tens of millions of years. By the time a million years pass, any giants in Voyager's path will have already lived and died. Their deaths will scatter heavy elements into the void, seeding the gas that will eventually birth new stars and planets. Other smaller stars will still be out here, stubbornly burning through their hydrogen fuel while the giants fade. Red dwarfs, those common little embers, can keep glowing for hundreds of billions or even trillions of years. The red dwarfs I see now will still be shining in a million years, while new stars emerge from the dust. Starbirth is a constant cycle out here. New suns are born all the time as gas clouds collapse under their own weight. Some of those brand new stars will light up the space around Voyager, joining the local neighborhood. Back home, if home still exists, people will have forgotten all about Voyager 1 for hundreds of thousands of years. It went dark in the late 2030s or early 40s when the power died. After that, it was lost to us. We have its last trajectory, but without a ping coming back to tell us where it is, the uncertainty only grows. We can estimate its path for decades, but over centuries that confidence fades. After thousands of years, we lose track completely. A million years from now, if humanity still exists in any form we would recognize, they won't have a clue where it is. That probe will be nothing more than a relic, a footnote from an ancient era when we first reached for the stars. Whether it is still in one piece or stumbled onto something strange out here, its final fate will remain a total mystery. Unless, of course, some advanced civilization develops the tech to hunt down ancient relics drifting through the deep dark of space. But why even bother? Why hunt for a tiny, silent, dead probe when the galaxy is full of billions of more interesting wonders? Voyager's path will be lonely and anonymous, just a quiet drift through the abyss with nobody watching and nobody knowing. Let's consider its fate over this massive timeline. It is drifting through what we call the local interstellar medium right now. That is the gas and dust filling the gaps between stars in this sector. It isn't smooth or uniform at all. Some parts are thick, others are empty. Some hold neutral hydrogen, while others are filled with glowing, ionized plasma. Magnetic fields shift from strong to weak. Voyager has to endure all these different environments over the next million years. Could it hit something? In the thickest parts of the void, there is only about one atom for every cubic centimeter. Imagine one single atom inside a space the size of a sugar cube. It is a perfect vacuum by any earthly standard. Compare that to Earth. At sea level, there are 2.5 times 10 to the 19th power atoms per cubic centimeter. That is 25 billion atoms in that same sugar cube. The air we breathe is incredibly dense compared to this void. So this space between stars is roughly 10 to the 19th power times less dense than the air back on Earth. Think of it this way. If we took every single atom in Earth's atmosphere and spread them across a sphere as wide as our orbit, one astronomical unit, you would get the same density as this void. Out here, hitting a stray atom barely does a thing. Voyager is screaming along at 17,000 meters per second or 17 kilometers every single second. When it clips a stray hydrogen atom, it just bounces off or gets brushed aside, barely transferring any momentum at all. The impact energy is tiny. An atom hitting at 17,000 meters per second only carries 2.4 times 10 to the minus 19th power joules. That is less energy than a single photon of light. You would need billions of those hits to even nudge Voyager off its path. Over millions of years, these impacts might slowly wear down the hull, grinding away a few nanometers from the forward shielding. But it is not a huge deal. The core structure will stay almost perfectly intact as it drifts. The real danger is hitting something bigger, like a stray grain of dust or a small pebble. They are incredibly rare out here, but they do exist. Tiny dust grains, just a few micrometers wide, are scattered all throughout this galaxy, like hidden mines. They are leftovers from dying stars or supernova guts. Over billions of years, this debris builds up into a thin, ghostly haze. These grains are made of different things. Some are rocky silicates like sand, while others are carbonaceous chunks of dark matter. Others are just icy, covered in frozen water or different volatile gases. These drifters are coated in organic gunk, forged by cosmic rays. If we hit a dust grain at 17,000 meters per second, it would be catastrophic. At those speeds, even a microscopic speck packs a punch you would not believe. Take a single microgram of grit, like a grain of fine sand. At 17,000 meters per second, it hits with 145 joules. That is like the force of a 1 kilogram weight dropped from 50 feet, all concentrated onto a single point. That energy is enough to vaporize the grain and punch a hole right through our hull. The impact creates a miniature explosion, with the dust and our surface material both vaporizing from the sheer heat. The scar might be tiny, but it is permanent. If that hit lands on a critical component or a sensor, it is game over. A hole in the dish ruins our signal. A direct hit on an instrument would destroy it entirely. Of course, by the time we hit a grain like that, our systems will have been silent for millions of years anyway. But the void is empty. Truly empty. We could drift for eons and never hit anything bigger than a single atom. Models differ, but most tell us that any ship crossing the dark will eventually take a hit from interstellar dust. We are talking once every 10 million years. Over 1 million years, there is maybe a 20% chance of a visible scar. That means there is a 90% chance we stay whole, weathered only by the slow sandblasting of stray atoms. But there is always that lingering fear. One big rock could end the journey in a heartbeat. Out here, the real monsters are rogue planets and asteroids, orphans kicked out of their own solar systems. They are incredibly rare, maybe 1 or 2 for every star in the galaxy, lost in the massive, frozen dark. So, the odds of us ever hitting one are basically zero, even over a million-year trek. I would be more worried about us drifting into a dense molecular cloud. These are spots where the gas gets thick, maybe 1,000 atoms per cubic centimeter, instead of just 1. These clouds are the nurseries of stars, stretching across hundreds of light-years of space. If we glide through one, the friction from all those extra particle collisions would start to strip us down. But even then, that thick gas is emptier than any vacuum we can make on Earth. The damage is minimal. The ship might lose a few more layers of metal, but nothing that would break our structural integrity. You have to wonder, could a passing star ever yank us onto a new path? Remember that star Gliese 445? It is our closest neighbor on the horizon for the near future. Passing within 1.5 light-years in 40,000 years, the gravity of that star will have zero effect on us. Let us look at the math together. It all comes down to Newton's law of universal gravitation. The pull is just the mass of the objects divided by the square of the distance between them. That star is a red dwarf, only about 12% as heavy as our Sun, which is massive on its own. Gliese 445 weighs in at over 29 zeros of kilograms, while we are just a few hundred. We will be 1.5 light-years apart. That is roughly 9 trillion miles of empty space between us. Crunch the numbers, and the pull is almost nothing, just 6 times 10 to the minus 14 newtons. That is a ghost of a force. A single human cell weighs 1,000 times more than that pull. That tiny tug only lasts while we are nearby, which is just a few thousand years in the grand scheme. Our course change would be less than a millimeter per second, far too weak to knock us off our path. For a star to actually steer us, we would have to drift within a few hundred astronomical units of it. At a distance of 100 astronomical units, basically the edge of a system a sun-like star would really pull on us. The gravity there would be millions of times stronger than what we will feel from Gliese. A close call like that could change our speed by kilometers per second, but the odds are incredibly slim. Stars are lonely. Out here, the average gap between neighbors is about 5 light-years. That is over 300,000 astronomical units. To get within a few hundred of a star, you would have to be incredibly lucky. It is like threading a needle in the dark. The space around a star is just a tiny speck in the ocean. Compared to the sheer size of the interstellar void, 100 astronomical units is almost nothing. Imagine a sphere around a star with that radius. It would cover 4 million cubic astronomical units. Sounds big, right? But the space around it is 35 trillion cubic astronomical units. We are just a ghost drifting in a desert. I am drifting in the dark, knowing the odds of passing near a star are just 1 in 9 million. Over 1 million years, I will watch Voyager pass through dozens of stars. A close encounter is unlikely, but never zero. Most likely, my fellow traveler will keep its distance, passing those stars by light years, not simple astronomical units. At those distances, gravity barely whispers. Voyager will stay its course, feeling only the tiniest tugs from the dark. However, a silent force is waiting to change its trajectory over millions of years. It is the gravity of the galaxy itself. The Milky Way is more than just a collection of stars. It is a massive gravitational structure, 1 trillion times heavier than our Sun. Most of it is haunting dark matter. This invisible matter does not emit light, but I can feel its pull. It forms a halo stretching far beyond us. This dark halo rules the deep where Voyager and I travel. Every atom out here obeys the galaxy's crushing command. That pull is dragging us toward the galactic center and down into the plane. Above the disk, it pulls you down. Below, it pulls you up. Try to run from the center, and it drags you back. The stars find balance in their orbit, spinning fast enough to hold the line against that relentless gravity. Their paths can last billions of years. But out here, Voyager is not following a stable circle. It is rushing at 10.6 miles per second, while our Sun carries us forward at over 100 miles per second. Around the galactic heart, that is 220 kilometers every second, is it moving fast enough to survive? If its velocity drops below what is needed for orbit, the galaxy will slowly pull it inward and down. Too much speed, and it drifts away into the void. These shifts happen so slowly you could almost miss them. The galactic pull is faint compared to a planet's grip. It takes millions of years for these invisible hands to redirect it. After 1 million years, its path will curve. It will no longer be traveling in a straight line. That trajectory will have bent by a few degrees, warped by the cumulative weight of the galactic field. It is a small bend, but real. If we ever hope to find it, we must calculate the galaxy's hidden influence. Simple math will not find it in this darkness. Now, let us look at the golden record together. Bolted to its side is a 12-inch copper disc, protected inside a gold-plated case. This is our gold-plated time capsule, a message in a bottle for any intelligence waiting in the darkness to find us. It was Carl Sagan's dream. He was the visionary on the team who wanted to reach across the void. He had done this before with the Pioneer plaques, small metal messages sent out on earlier missions. Those plaques showed our faces, a map of our home world, and a few basic signs of life. For Voyager, he wanted more. He wanted our sounds and our colors to speak for themselves. He gathered a small crew of brilliant minds to decide what of our world was worth saving for eternity. They had less than 6 months before launch. They managed to cram 116 images inside. Using old analog technology, the pictures are hidden within audio signals. The instructions are etched right there on the cover. The images capture our fleeting existence, showing people from every corner of the planet living their lives. There is a mother nursing, children at play, and families eating together. They even sent images of an elephant and an eagle. They included tiny insects and vast landscapes, from desert sands to the deep blue of the oceans. Our great monuments are there too, alongside diagrams of the very cells that make us human. They mapped our DNA, our atoms, and the math that governs the stars. They sent our blueprint into the night. It shows where we are in the galaxy, a small coordinate in an endless ocean of black. Every picture was chosen carefully. They wanted to show who we were without getting lost in the details. They left out our wars and our blood. They wanted the universe to see us as curious, kind, and full of life. The record also carries greetings in 55 different languages, echoing through the silent vacuum. Each voice is just a few seconds long. Some are formal, reaching out from the inhabitants of our world. Others are just children saying hello, or poets wishing for peace among the cold, distant stars. Those voices prove how different we are, yet they all share that same desperate need to connect. Even the Secretary General of the United Nations added his voice, speaking for us all in English. And finally, a greeting from then-President Jimmy Carter. In English, it reads, "This is a gift from a small, distant world, a token of our sounds, science, images, and music, our thoughts and feelings. We are trying to outlast our own era, so we might live on in yours. It captures our achievements and our fragility. We are trying to survive our own time. You and I know the odds are slim, but we hope it is found in the distant future. They will know we tried, that we cared, and that we dared to reach across the void. The record holds sounds from nature. Wind in the trees, rain falling, thunder, and waves hitting the shore. Volcanic fire, animal calls, and the song of a humpback whale. Chirping birds, barking dogs, and crickets plus human life. Footsteps, laughter, a baby's cry, a steady heartbeat, and the soft sound of a kiss. These sounds define the world I see below. You and I are part of that acoustic environment, even out here in space. The rush of water, the howl of wind. These are universal things that would exist on any planet wrapped in a thin atmosphere. Others belong only to Earth, like a whale's call or a child's laugh. The record holds 90 minutes of music from every corner of our world. Bach's Brandenburg Concerto No. 2, Beethoven's Fifth Symphony, Mozart's Magic Flute, and the raw power of Stravinsky's Rite of Spring. This classical music represents centuries of tradition from one side of our world. But the creators did not stop at just Western sounds. They added music from many different cultures, a girl's song from Zaire, Navajo chants, Japanese flutes, Indian ragas, and the strings of Chinese music, Peruvian pipes, Georgian folk, Senegalese drums, and Mexican mariachi. They even packed in some of the modern, popular music of the West. Chuck Berry's Johnny B. Good, a rock anthem from the 1950s, plus Louis Armstrong's trumpet playing the melancholy blues. Blind Willie Johnson's Dark Was the Night, Cold Was the Ground, from the 1920s. Choosing the music was a massive, daunting task. How do you pick 90 minutes of music to represent all our achievements? What do you take with you, and what gets left behind? They balanced the globe, from ancient chants to modern hits, voices and instruments alike. They tried to capture the diversity of our species. But out here, I know no list could ever be complete. Any choice would end up leaving out much more than it saved. Finally, they chose music representing the heart of human culture, hoping it would sound beautiful to any listener out there in the dark. This record was built to last billions of years. Gold does not corrode in the cold, silent, empty vacuum of space. No oxygen to rust it, no water to melt it, no bacteria to consume it. The grooves in the gold will stay sharp forever. Unless hit directly, the aluminum cover shields it from the tiny dust grains and particles that whip through this silent, empty void. If something hits the craft hard enough to break the record, it would likely destroy the whole ship. The record's life is Voyager's life. In 1 million years, if Voyager has not been crushed by a collision or ripped apart by the gravity of some massive ghost star, the golden record will remain, its secrets waiting for anyone with the tech to read them. But they must understand the analog past. The record has instructions etched right onto its aluminum shell. A diagram shows how to pull an audio signal from those deep grooves. It marks the playback speed using the frequency of hydrogen atoms, a fundamental law of physics that any spacefaring species should recognize immediately. There is a diagram showing how to decode images from the sound, detailing the scan lines and how long each picture should last. There is even a guide on how to build a stylus to play it. But these blueprints assume the finders are technologically advanced. Whoever finds Voyager will need to understand radiation, atomic structures, and the complex ways we encode our existence into signals. They will need the tech to catch the craft, extract the disk, and build a device just to hear our long-dead ghosts speak. That is a massive gamble for some alien race that might have evolved along a completely different path of science and discovery. They might use alien physics, strange math, or unknown ways of storing data. They might not even possess a sense of hearing. If they communicate through glowing light or telepathy, the sounds on this record would be nothing but silence and noise to them. But this was never about practical talk. Carl Sagan knew the odds of someone actually finding Voyager were almost impossibly small. The craft is a speck in an infinite ocean of stars. The chance it passes near a living planet is basically zero. Even if millions of civilizations are out there, they are scattered across billions of cubic light-years of cold, empty space. Voyager is a needle in a cosmic haystack, so vast the analogy fails. Let's consider it a statement, a pure gesture of human curiosity. It is a way of saying, we were here, we lived, we built this and threw it into the void because we wanted to reach out. We wanted to connect with something beyond us. Let's hope this message reaches a civilization billions of years from now. This will be after our sun turns into a red giant and burns Earth away. In that future, long after we have vanished, Voyager and its gold disk might be the only proof we were ever here, a lonely ambassador drifting forever through the dark. It carries the sights and sounds of a world that is no more. Carl Sagan called this record a message in a bottle. It is a letter tossed into the cosmic ocean. But most messages in bottles are destined never to be found. They drift for centuries, slowly breaking apart until they sink or finally wash up on some strange, distant shore. Most get swallowed by the void, but a few survive. From up here, I imagine a beachcomber finding a bottle, reading a note, and suddenly feeling a bridge across the stars. This golden record is our message in a bottle. We don't know who might find it, or if anyone is even out there. Sending it was the point. It defines us, a species that looks out from the cabin window and refuses to stop wondering. We're a race that builds machines to bridge the cosmos, creating art just to share it with whoever might be listening. 1,000,000 years from now, that record will still be out here, drifting through the eternal black with our story. It'll be waiting for someone to hear the echoes of Earth. 1,000,000 years, it's a span of time impossible to grasp. Our entire history of cities and farming only stretches back 10,000 to 12,000 years. Recorded history is a mere 5,000 years. Our species has only existed for roughly 300,000. 1,000,000 years is 3 times our entire lifespan. Looking back, 1,000,000 years ago, our ancestors weren't even modern humans. They were Homo erectus, upright but small-brained. They had fire, but no language to describe the stars I see now. No art, no cities, no writing. Everything we've ever achieved fits into that one staggering window of time. From hand axes to this spacecraft, from cave fires to the internet, everything happened in less than 1,000,000 years. Everything that defines us is packed into a timeline shorter than the journey Voyager is just beginning. Now, look forward. 1,000,000 years into the future is as far ahead of us as we are from those ancestors. The shift will be profound. 1,000,000 years is plenty of time for evolution to forge entirely new species. If we still exist, we'll have evolved into something else, something unrecognizable to those of us alive today. Our bodies might adapt to alien gravity or toxic air. Our brains could be restructured entirely by the void. We might split into different species, adapted to different planets like Darwin's finches on isolated islands. Or we might even engineer our own evolution, redesigning ourselves for deep space travel or superior intelligence. Or we might leave biology behind, merging with AI, or uploading our minds into machines beyond our current imagination. The line between man and machine might vanish forever. What we call human could become a strange hybrid of organic and synthetic. Or we might simply be extinct. Our time could run out, just like 99% of all species before us. War, asteroids, or rogue AI. Disaster could end it all, or we might just fade away until the last of us dies alone in the quiet dark. Looking down, I see empires rise and fall in mere centuries. Rome lasted 500 years. The British Empire peaked and fell in just 300. Everything is temporary. Every great civilization has eventually crumbled, transformed, or been swallowed by the sands of time. Societies only last a few thousand years. Ancient Egypt held on for about 3,000. But over time, everything changed. The gods, the laws, the technology. It was never the same Egypt for long. By the end, they couldn't even read the symbols their own ancestors had carved into the stone. Languages drift so far in 1,000 years that they become complete mysteries. English from 1,000 years ago is unrecognizable now. Speak to someone from 1026, and you'd both be lost. It would sound like a foreign tongue. Go back 10,000 years, and every word spoken has vanished without a trace. We have no idea how they sounded or what their voices could even express. They are gone, vanished with their cultures. Now, multiply that silence by 100. In 1,000,000 years, no language will share a single word with what we speak today. It will all be erased. Everything will be different, evolved far beyond our recognition. Our cultures and our beliefs will be forgotten or replaced by things we can't imagine. Our religions and our science will be ancient myths, if they are even remembered in the deep future. Future civilizations might study us the same way we study the ancient Sumerians. They will piece together our ruins, trying to understand our lives, or we'll be dust, completely forgotten in the void. Unknown to the future, yet Voyager will still be out here, carrying a record of a world that no longer exists, drifting through the black on a journey, with no destination and no end. There's a haunting beauty to Voyager's lonely path. It is the very best of us, still reaching out. The hunger to explore, the genius to build machines that survive the void, and the haunting hope that we aren't alone. Voyager is the ultimate testament to our drive. It is a mark left on the cosmos, pushing past every known limit. Think about the hands that built it. Thousands of souls working together for years down there while looking up here. Engineers had to design systems that wouldn't fail for decades. Out here, there is no repair crew and no second chances. They chose gear to last lifetimes. Programmers wrote code for computers weaker than the basic calculator in your pocket right now. Technicians pieced it together with terrifying precision. Every bolt and every wire had to be absolutely perfect. This was when we were still learning how to survive the jump to the outer planets. Space was still a new frontier. The mission was a massive web of coordination. From the Jet Propulsion Laboratory to NASA centers, everyone was locked in. Every subsystem came from a different corner of the country. Universities and NASA labs poured their genius into this bird. Private contractors and scientists worked as one. They solved impossible problems under the ticking clock of a rare planetary alignment. Out here, reliability is everything. The design had to be flawless because the void is unforgiving. One shot, no repairs and no pit stops. Every system had to wake up and stay awake for years on end. They built backups for the backups. If a primary system died in the dark, a silent ghost had to take over. Computers could pivot modes, and instruments could be rebooted from millions of miles away, a digital lifeline across the stars. But even with all those safety nets, the fundamental bones of the craft had to be indestructible. Materials had to survive the sun's scorching heat at launch and the soul-crushing cold of the outer solar system. Electronics survived Jupiter's radiation doses that would kill me in minutes. Mechanical parts had to move after years of frozen silence. Testing was exhaustive. They pushed every component until it screamed, then tested the whole spacecraft over and over again. Engineers simulated the hell Voyager would face: vacuum, vibration, and radiation levels that truly defy human imagination. They mapped the path through every gravity well, calculating every tiny course correction with absolute mathematical certainty. They planned every single activation. Back in 1977, the bill was $865 million. That is $4 billion today. A massive price tag, but look at the secrets we bought with it. 2 ships that rewrote the maps of our solar system. Images that sparked a fire in the minds of future explorers. They changed how we see worlds. We realized Earth isn't just a lonely dot, but part of a crowded, diverse neighborhood. Now, 48 years later, one is still talking to us. It is screaming back data from past the edge of everything. Nobody expected this. It was supposed to be a 5-year trip, maybe 10 if everything went perfectly. They built in safety margins, sure, but half a century later, no one could have predicted this machine would still breathe. It is a tribute to the team, to the legends who built a machine that simply refuses to stop its journey. As the nuclear heart fades, the crew makes hard choices. They are killing parts of it to keep the rest alive. The cameras are dark now. There is nothing to see in the abyss. Heaters are off, leaving components to freeze in the deep. One by one, Voyager's systems are being put to sleep, carefully managed to squeeze out every last bit of data before power vanishes. But a few instruments are still running in the dark. The cosmic ray detector is still listening, and the magnetometer feels the faint pulse of the space between the stars. The plasma instrument hears the vibrations of the void, while other sensors watch the solar wind finally fade into the interstellar sea. These instruments are touching things no human-made object has ever felt before in the history of our species. As long as it has a pulse, Voyager will push deeper, whispering secrets from a realm we have never known. It is haunting, really. Voyager is on a one-way trip into total oblivion. It will almost certainly never be found. That message it carries? It will probably never reach another soul. It is a letter sent to a mailbox that doesn't exist. It will drift through the silence for billions of years until a stray star finally swallows it or tidal forces tear it apart. Or it might just crumble over eons from the radiation. Imagine the quiet loneliness of that infinite, empty crawl. It is fleeing the only home it has ever known, escaping its creators for a darkness so absolute it defies our understanding. Right now, Voyager is further from any human being than any object in history. It is truly, utterly alone. The astronauts who reached the moon were only 239,000 miles away. They could still see our blue marble. They had a 1-second delay. Voyager is 15 billion miles out. That is 24 billion kilometers of silence. That is 62,000 times farther than the Moon. From where Voyager drifts, Earth has simply vanished. From my view, the Sun is just another star. It is brighter, sure, but it isn't special. Everything Voyager ever knew, everyone who ever built it or worked on the mission, is contained within a single, tiny point of light that is now indistinguishable from all the other cold stars in this vast sky. Every second, Voyager slips further away. Every day, it covers about 900,000 miles, roughly 1.5 million kilometers, as it drifts through the dark. Every year, it travels about 326 million miles, covering 525 million kilometers. The distance between us just keeps growing, and we can't stop it. There is no rescue. It is gone. In a few decades, the power will die, and it will go silent forever. The final whisper will be received by those giant radio dishes back on Earth, the same ones that have been listening to its faint heartbeat for decades. The signal will fade, growing weaker until it is finally swallowed by the noise. Then, there will be nothing but silence. No more data, no more transmissions, and no more contact with home. Voyager will drift on, but we won't know where it is anymore. We won't know if it is still whole or shattered by a stray rock. It will be beyond our reach, drifting in the dark forever. All we will have left are the math and the old predictions from the last time we heard its voice. Eventually, even those guesses will fail as the errors pile up. But maybe that is exactly how it should be. Maybe the true value of Voyager isn't where it's going. Maybe it's in the act of sending it the fact that we built it, launched it, and sent it into the universe knowing we'd never see it again, knowing full well that we would never see it again, never knowing its end, getting nothing back but a few decades of radio pings and grainy images of the dark. We did it anyway because we needed to reach out. We wanted to say to the universe, we are here, we exist, and we are still wondering what else is out there. That hunger to explore is in our blood. It's in we have. Looking out at the stars now, I know we have always been drifters. My ancestors left Africa eons ago, crossing mountains and frozen plains, settling in every corner of the world just to see what was there. They had no maps, no GPS, no help. They just walked, following the coastlines and always wondering what was hiding behind the next ridge or the next horizon. The first humans to cross the Bering Bridge into the Americas walked into a completely unknown world. They had no idea how far the land went or what dangers were waiting for them. But they kept moving, century after century, pushing south through the continents, all the way to the jagged, icy tip of the world at Tierra del Fuego. It was a journey of thousands of miles on foot, undertaken by people who knew they would never see the destination, but they kept moving into the unknown anyway. The Polynesians pulled off some of the most audacious voyages in human history. They sailed across thousands of miles of open ocean in tiny canoes, navigating only by the stars, the waves, and the flight of birds. They sailed into the massive blue of the Pacific, never knowing if they would find a new home or simply die of thirst. Many never returned. Boats were lost. Entire crews vanished into the deep, their fates swallowed by the ocean. But some made it. They found tiny islands, built a life, and then looked back at the sea and left all over again. This is how humanity settled every corner of the earth. Through exploration, through immense risk, and a willingness to venture into the unknown even when success was far from a guarantee. Plenty of them died out there. Many never found what they were looking for, but they kept going, driven by that hope for something new, something worth the sacrifice of discovery. That same fire fueled the old explorers. They sailed uncharted seas, half expecting to fall off the edge of the world into the abyss. Columbus headed west in 1492 with 3 tiny ships and 90 men who were probably terrified. He really thought he was hitting Asia. He had no clue 2 massive continents were standing in his way. If the Americas hadn't been there, his ships would have run out of food and water long before reaching Asia, and every soul aboard would have perished. He got lucky, in a way, even if his arrival was a total disaster for the people already living there. Magellan's crew set sail in 1519 with 5 ships and 270 men against the unknown. Only 1 ship limped back 3 years later, with 18 survivors. Magellan himself died. Most of his crew died from starvation, disease, or violence. The voyage proved the Earth was round and much larger than we thought, but the cost of that knowledge was staggering. The cost was brutal. Yet, the ships just kept leaving the docks. More ships sank. More sailors died of sickness and drowning. The sea was a graveyard. But they kept sailing until they finally mapped the entire globe, connecting worlds that had been isolated for eons. That same restless hunger is what drove us to start the space race. The choice to go to the moon wasn't because it was easy, it was because it was hard. Kennedy said it best in his 1962 speech at Rice University. We choose the moon in this decade and push ourselves further, not because it is easy, but because that goal forces us to organize and measure the absolute best of our energy and skills. We were willing to risk lives and massive wealth for the impossible. The Apollo program cost $25 billion in 1973, over $150 billion today. It took the hard work of 400,000 people at NASA and private firms to get us off the ground. 3 of my brothers died in the Apollo 1 fire back in 1967. We flew to the moon trusting technology that was brand new and barely tested. Apollo 13 almost ended in a grave disaster when an oxygen tank blew. We had to abort the landing and sling around the moon just to get home. My crew survived on sheer grit and a ship that refused to break under pressures it was never meant to handle. But we kept pushing. In July 1969, Neil and Buzz walked on the dust while Michael watched from high orbit. It was our greatest victory. We proved we could leave our cradle and step onto another world. That same hunger drives Voyager's long haul. You and I didn't send it out there for gold or colonies, or to find new neighbors in the deep. We sent it because we had to know what was in the dark. The universe is vast, and we are simply too curious to stay home. Voyager is the cold, metal manifestation of that human curiosity. A machine built to go where we cannot to see what our eyes never will. It answers the questions we've whispered since we first looked up. It carries on a legacy that started when our ancestors first walked out of Africa and into an unknown future. Let us put this in perspective. Voyager 1 left the launch pad on September 5, 1977. It has been drifting for 48 years now. In that time, it has covered 15 billion miles, 24 billion kilometers of empty space. To us out here, that distance sounds like an enormous stretch, and it is. 1,000,000 years from now, Voyager will have covered over 300 trillion miles. That is roughly 22,000 times farther than it has traveled so far. If we scaled its current distance from the Sun down to a single step about 3 feet or 1 meter, then the distance it covers in 1,000,000 years would stretch about 14 miles. A journey that began with one small step will eventually cover the length of a marathon many times over. Yet, when you look at the scale of our entire galaxy, Voyager has barely moved. The Milky Way stretches about 100,000 light-years across. By then, Voyager will have crossed 56,000 light-years, which looks like it reached halfway across our home galaxy. But remember, it is not crossing the whole disk. It is just drifting through a small corner of one spiral arm as the stars shift around it. Our Sun will have moved along its own orbit, but the overall structure of the galaxy will look exactly the same. From out here, Voyager's journey is a tiny, invisible crawl, a speck of dust shifting slightly in a massive cosmic cathedral. But for us humans, it is the farthest we have ever reached, a mission that will outlast our cities and perhaps our entire species. You and I have to remember that Voyager 1 is not out there alone. Its twin, Voyager 2, launched 16 days earlier on a different path through Jupiter, Saturn, Uranus, and Neptune before heading into the void. In 1,000,000 years, Voyager 2 will be lost in a completely different part of the star map. Tens of light years will separate them. These siblings, born together on a pad, will have diverged completely, never to see each other again. They will never be close again. They are family members who said goodbye and walked into different ends of the night. There are other human ghosts out here too, other machines leaving the safety of our solar system behind. Pioneer 10 and 11, launched in the early 70s, are out here in the silence, though they stopped speaking to us decades ago. New Horizons is on its way out past Pluto. It is moving slower, and it will not reach the interstellar void for many more years. All of these ships are heading in different directions, lost to the dark. They are like seeds we scattered into a galactic wind, drifting away from us. In 1,000,000 years, they will be spread across hundreds of light years, each carrying a frozen remnant of humanity's early ventures into the deep. They are our first interstellar messengers, the first time Earth has ever sent something out to live in the larger cosmos. Before them, every single thing we ever built stayed trapped within the Sun's heavy gravitational influence. Now, we have hurled pieces of ourselves beyond that final boundary, into a dark realm that our physical bodies may never actually reach. So, where will Voyager 1 be after a million years of silence? It will be roughly 56,000 light-years from where the sun sits, drifting through the Milky Way's Orion arm among stars we haven't even named yet. It will be a cold, dead husk. Its power long exhausted, its metal skin silent and dark. It will glide past countless suns, through dust lanes and voids, without a single thing ever marking its lonely journey. But it still carries the golden record, our message to the stars, waiting for a listener who will almost certainly never come. And still, it will keep moving. So what do you and I make of this lonely traveler, still screaming through the void at 10.7 miles per second, a million years after leaving home? Looking out from this station, Voyager feels like a chilling mirror for us. We are just tiny, fragile ghosts on a small, temporary world. I see how we flicker for a moment in cosmic time, then vanish. Yet, while we are here, we reach into the cold unknown. We build, we launch, and we cast our creations into the void, knowing they will almost certainly never return or find their true purpose. We do it because we are driven by a primal need to leave a footprint. We have to say we were here. We must touch stars. Voyager 1 is that silent legacy. A small, lonely machine carrying the haunting hopes of a species that wanted to reach far beyond itself. 1 million years from now, when it is drifting through regions unimaginably far from home, the hands that built it will be cosmic dust. This Earth I am watching might not even exist. The civilization that launched it will have either transformed or simply vanished into silence. But Voyager will still be there, drifting. There is something eerie about that lonely journey through the shadows, a persistence in the face of nothingness. It is a reminder that even these fragile bodies can create things that last. You and I can reach far beyond our own horizons. We can touch eternity, if just for a second. Voyager 1 will spend the next million years as a witness, proving to the void we existed. It proves we looked at these stars and wondered. It shows we had the courage to cast a piece of ourselves into the unknown. You and I have shared this trek across the light years. Now, Voyager's next million years will unfold in total silence and absolute darkness. No one will be watching. But tonight, we have traced its path and honored the staggering achievement of a species reaching for the infinite. Keep looking up. The universe is vast, strange, and hauntingly beautiful. Somewhere in that deep blackness, our small machine carries a piece of us toward forever.